All right. We were discussing these points. Okay. So electrons from the surface of the metal are removed, of course, because they are escaped. Okay. A single photon can only interact and hence exchange with a single electron. One-to-one interaction is there. One photon cannot take three electrons out of the surface. Uh, uh, so it's a one-to-one interaction only. A surface electron is removed instantaneously from the metal surface when the energy of the incident photon is greater than or equal to the work function phi. Or in easy words, you can say that if it has a threshold frequency or more than that frequency, your electron is going to get escaped. Okay, so if the photon which is incident on that particular metal, if its energy is greater than the work function phi, then the electron is going to get escaped, else it will be just lying there on the metal. Energy must be conserved when the photon interacts with an electron. Of course, it will be conserved because some of the energy is taken by the electron to get escaped, and the other one is going where it is going to rest is the electron's kinetic energy. Okay. Increasing the intensity of the incident radiation does not release a single electron when its frequency is less than the threshold frequency, as I explained it. Okay? So, whenever the intensity is not that much high, if the energy is not that much high, even though the intensity of your light is very much high, it doesn't matter. Your energy needs to be high. Okay? So, don't confuse between the intensity and the energy, because energy is basically dependent on the frequency as well. You need a very a minimum amount of frequency to make that particular electron, to give that particular electron that energy to escape. Okay, so don't confuse between the intensity. Increasing the intensity of the incident radiation does not release a single electron when its frequency is less than the threshold frequency. Very important point, students, very important points. Okay. Now let's move over here and let's see that this particular derivation. Your HF, now they are saying that now your energy is what? Energy was HF, and they are including calculating H is what? It's the Planck's constant. Okay, I hope you guys remember this. And your frequency, they are equating it that it is actually equals to two things. What is it? One is the phi, which is the energy required for the electron to actually get escaped, and the second one is your kinetic energy. Oops. Your kinetic energy is what? It is half mv square. So let's derive it. Your phi plus half of mv square is what your HF is actually equals to. Now, here, this equation shows that as Einstein's photoelectric equation. So it is the photoelectric equation of Einstein. Okay, we start with the photon of energy HF. We always say that electron, your photon, sorry, your photon energy is, we say that it is HF. This energy is actually absorbed by the electron. Okay, and some of it is absorbed, and the energy is used in escaping from the metal, and the rest is as the kinetic energy of the electron. If the photon is absorbed by an electron that is lower in the energy well, the electron will have less kinetic energy than kinetic energy max. Okay, so it also depends that where your electron is actually lying in the well. So your HF is equals to phi. So the kinetic energy of the electron is 0. Hence, according to Einstein photoelectric effect, this thing is going to get happen, and your F naught is equals to phi. You're just rearranging this stuff. Okay, and in this diagram, they are actually explaining the whole thingy, that if you have more tightly electrons binding over here, so all of the energy will be taken by the electron to go out, and no kinetic energy will be there. Okay, because the energy, all energy is taken up by that particular electron. The energy is still conserved. Okay, so in the previous one, when it was like lightly bonded here, yeah, for example, they are lightly bonded, so it is going to take the electron with it, and kinetic energy, some of the kinetic energy will be left. Okay, some of the kinetic energy will be there. Okay, over here, all of the energy is taken by the electron to escape from this particular thing here. These are the trapped electrons inside it. Okay, More tightly bonded electron needs more energy to release it from the metal. Okay, a single photon may interact with a single electron to release. So these are the very important points. Okay, now your homework. This is your homework. This table actually summarizes whatever we studied till now. Okay, it will tell you the observations, what you observed, when the photoelectric effect is actually happening, what does the wave model tells about you, what does the photon model tells you about it. So this is your homework. You need to read this and write it in your own words. The submission date is Sunday. Thank you so much.